We have arrived at question number 13 of RACE-0 of the Secureum Bootcamp. As you can see, it is now about the security concerns in the given proxy-based implementation. And before we continue here, I would like to very quickly review what proxies even are and what they even do. So proxies are just like any other contract. They have an account with an address, and they have a value, so a value, an ether value, and funds associated with their address. They have their own storage, and they have their own code. So this is a proxy. Now, a proxy code is usually not very large. A proxy code usually does not much more than doing a delegate call to either a hard-coded address or to an address that is in the proxy's own storage, basically. But otherwise, they don't do much. Where the actual code of the DeFi protocol is in the implementation. The implementation 2 is just a contract with an address. Just as any other, it has its own value, its own storage, and its own code. Now, why would anyone use this complicated construct? Thing is, when you use a proxy, you can basically change the code while keeping the storage that you have, all the storage variables that you already have, all the mappings, all the balances that you have in the proxy. You get to keep the value that you have, you get to keep also all the other funds that are associated with the address, because you keep the same address. So you can basically change what your code does without changing anything else. And that can be quite useful. And the way it does that is that the code, the proxy code, does not do much more than just delegate calling to the implementation. And the effect of delegate calling the implementation is basically that this code is taken and it's basically put into the proxy. So now the code of the implementation is inside the proxy. The code of the implementation has access to the storage of the proxy, access to the value, to the ether value of the proxy, and it can even make use of the address that the proxy has. And therefore it can also make use of all the funds that are associated with the proxy's address. So a DeFi protocol, let's say we have a dApp that accesses a web interface, for example, that accesses the contracts of its own protocol. It would always send its transactions to the proxy, and if at any point they need to switch the code of their application, they would just basically change whatever implementation address is stored within the proxy storage, change it to something else, and then this delegate call would suddenly go to a different implementation, and it would get different code. It would no longer use the old code, it was used new code. Now, one important thing here to know is that basically the application is only using the proxy. That means there shouldn't be no calls happening directly to the implementation. We don't want that, we don't need that. The implementation, all it does is provide the code. That's all it's supposed to do. Therefore, we don't need the implementation's address other than being able to delegate call to it. The implementation should not have any value or any funds, and the implementation should not make use of its own storage. The only reason for the implementation to make use of its own storage is basically for the implementation to make sure that the implementation can prevent itself from being used. If there is some variable that needs to be initialized to make sure that it cannot be used, then this this implementation should set this variable to make sure that it cannot be directly called or used by anyone. And the next thing that is important to know is that we cannot make use of constructors. When you deploy code to the blockchain, what you send to the blockchain is the initialization code, basically. And this initialization code, it contains the constructor and some other code, and it also contains inside it the actual code that will end up there, or maybe it's not quite finished yet, maybe it needs some adjustments basically from the constructor, but the actual code that will be deployed is inside of this initialization code, and the constructor is outside of the actual code that is being deployed. So the constructor is actually gone. Once it's been executed, once the initialization code has generated the actual runtime bytecode, all the constructor and everything else that is related to constructor is gone, and instead we only have the generated code in the implementation. And that is important because that means if we have anything in the constructor that initializes storage variables, we cannot make use of that. We are not allowed to do that because the constructor trying to set values within the storage would set them within the implementation, and we don't want to use the implementation. So what we want the constructor to do is set those values in storage of the proxy, but it can't do that. That's a different contract, so it's not able to do that. So for the most part, we're just not gonna use a constructor. The only reason to use a constructor in the implementation is basically to make sure that the implementation cannot be called directly. Otherwise, we don't use constructors in the implementation. Instead, we use initializers. And initializers are just normal functions. They're just functions inside of the code. Inside here is an init function. It does the same thing that the constructor would have done. And since this init function would then also be here, when called, it can then properly update the storage variables within the proxy instead of doing it within the implementation. But that comes with problems because the initialization function being part of the normal code also means that it is normally callable by potentially anyone in the world, multiple times callable, but maybe it should only be callable by the admin, maybe it should only be callable once, like a constructor basically. The big advantage of using constructors is that they are only executed once, they can never be executed again, and that they are only executed by someone who is authorized to execute them, by the person deploying the code. And we no longer have these advantages automatically within this initialization function. So we need to work around that by making sure that these things cannot happen, basically. And we will see that this is important in this snippet in question very soon, because A says imported contracts are not upgradable. So we have only one imported contract here, and it is from OpenZeppelin, but this time it's not the normal OpenZeppelin contracts. This time it's a special package which is called OpenZeppelin Contracts Upgradable. And as the name says, the difference is to the normal OpenZeppelin contracts. They basically contain about the same contracts. The difference is that those are upgradable. And why are they different? How are they upgradable compared to the normal OpenZeppelin contracts? Well, for one, they're not using constructors. They're only using constructors to prevent the implementation from being callable, basically. But otherwise, those upgradable contracts make use of initializer functions instead of constructors. And we can see that that from this package we use the initializable contract, which is then extended by our test contract here. And the initializable contract from OpenZeppelin basically gives us that which we are missing from the constructor. It allows us to make sure that our initializers are only called once, and that they're only called during the deployment of a new version, for example. And it also has more features, like we can keep track of which version is initialized and make sure that a version is only initialized once when a new version is deployed. It can tell us whether it is currently in the process of initializing, or if it is not initialized at all, or if it has already been initialized, and all those kinds of things. But A says here that the imported contracts are not upgradable, but they're literally from the contracts upgradable package, and there's no other contracts being imported here that are not upgradable, so A is not correct. Next, B says that multiple initialize calls are possible, which allows anyone to reset the admin. As we can see here, we have this initialize function, which would have been the constructor basically, and it is external, and it does not have any modifiers. That's bad, because extending initializable alone doesn't give us these nice constructor-like features. Instead, what we have to do, we have to add initializer to the initialize function. There is a modifier called initializer, and we have to add it to all the initialize functions that are contained in our code in order to make sure that this initialize function can only be called once, basically. Since this function, initialize, can be called multiple times by anyone can basically set a new admin. So that is definitely a problem. Then we have C. Rewards will be 0 in the proxy contract before set rewards is called by it. So we have set rewards here, which sets the rewards, but only admins can do that, which is fine. But you can see here in the initialization of rewards, it is set to 10. So the problem of this is that this setting to 10, it's not in a constructor, but it is actually part of that same initializing bytecode that is deployed, just like the constructor. So what would happen here if we deploy this code? So this entire contract test is the implementation, by the way. So this is not the proxy, this is the implementation. And deploying this implementation would basically set rewards to 10 in the implementation, but we don't want it to be set to 10 in the implementation. We want it to be set to 10 in the proxy, and for that we have to move this into the initialize function. So we need to set rewards to 10 within the initialize function instead, and it being set outside of it is certainly a concern. So C is also correct. All of the above can be true since A is not true. And that's it.